Okay, welcome back guys. In today's video we have a question very similar to what we previously solved in the channel, and we have these two links of AB and DE that are connected by a bell crank, and we need to determine the maximum force that may be safely exerted by link AB on the bell in a condition that the maximum reaction at point C is 600 Newton. So we're going to start with the free body diagram. So we have a pin at point C, which means we have both X and Y component, and we have the force, the length AB, and we have the force of the length DE. And that's pretty much all the forces that we have regarding the dimensions we previously showed in the previous question, that if we want to find these dimensions, this will be 5430. We explained in the previous question. You guys, I'm going to put the link in the description in case you want to check that one out. So let's go with our equilibrium equation. So obviously we are in equilibrium, so we can use our equilibrium equation, sum of all forces in X and Y equals 0, and same for the moment. So in the previous question, we did the moment about point C equals 0, and from that we figure out that the FDE was 5/6 FAB, and we're going to use that in this here. So if that's the case, we can do our sum of all forces in X and Y direction. If we go with X, we'll have CX minus FAB. The X component will be 3/5 equals 0, and from here we can find our CX, which will be 3 divided by FAB, and we can move on to our FY equations. So we have CY minus FDE minus FAB, and this time we will have the Y component of FAB, which will be 4 divided by 5 equals 0, and from here we can replace FDE with FAB. Again, we know FDE is 5/6 of FAB minus 4/5 of FAB equals 0. And if we add these two, we can conclude that CY is equal to 5/6 FAB plus 4/5 FAB. And we can factor FAB, and we will have 30 in the denominator, so this will be 25, and the second one, this times 6, this times 6, 24 FAB, and that would be our CY will be 49/30 times FAB. So we found CX and CY based on FAB, and we have an important information in the question that the magnitude of C cannot be more than 1600. So if we go for the max of C, we'll have CX squared plus CY squared. So we'll have 1600 equals to, in order to have same denominator for CX and CY, we know CY is 49 divided 30. So here, if we multiply numerator and denominator by 6, we will have 18/30 FAB. And if that's the case, we can take 1 divided by 30 out of the square root, and we will have CX 18 squared plus 49 squared. And if we do that, and obviously we have FAB out of the square root, so obviously this will be times FAB squared 2. And here we can find our, so here 1600 will be 1.74 FAB, and from here we can find our FAB, which will be 920 Newton. And that would be the final answer for this question. Again, I'm going to put the link for the previous question that was very close to this one for finding the angles and the beginning part of the moment about point C. So that would be all for this question. You guys take care, and I'll see you in the next one.